3 years ago, NASA launched the most powerful space telescope in human history, the James Webb, a machine designed not just to see stars and galaxies, but to peer through time itself, to look so far into the past that we might glimpse the birth of everything. But no one, not even the most optimistic scientist, expected this. Because Webb hasn't just captured distant galaxies or revealed baby stars in cosmic cradles. It has shattered timelines, exposed impossible structures, and uncovered objects that should not exist. Not yet. In fact, some shouldn't exist at all. What started as a scientific mission has quietly become something else entirely. A full-blown unraveling of the universe's deepest secrets. And it all begins with a single chilling realization. The universe was never what we thought. And now, thanks to Webb, it's starting to show its true face. When Webb aimed its golden eye at the farthest corners of the cosmos, scientists expected to see infant galaxies, messy, chaotic, barely formed specks of light born shortly after the Big Bang. But that's not what it found. Instead, Webb revealed fully grown giants, massive structured, glowing galaxies that looked like they had skipped childhood altogether. Some of these ancient galaxies appeared just 500 to 700 million years after the Big Bang, which in cosmic terms is barely enough time for gravity to pull together a dust cloud, let alone craft an elegant spiral or elliptical shape. Even more disturbing, some of these galaxies emit light so intensely they seem older and brighter than they possibly could be. How did they grow so fast? One theory points to hidden supermassive black holes in their cores whose violent radiation might make these galaxies appear deceptively large and bright. But the truth is, even with that explanation, the timeline doesn't add up. Something formed these behemoths at breakneck speed, faster than any model of galaxy evolution can account for. And it's forcing cosmologists to rewrite the opening chapters of our universe with a big red question mark. The James Webb telescope wasn't just built to take pretty pictures. It was designed to collect data across light spectrums no other instrument could reach. And in doing so, it's uncovered something even more unsettling. The universe might be lying about its age, or at least about how it grew up. Critical measurements, like the Hubble constant, which tracks how fast the universe is expanding, don't match depending on where we look. Webb's readings from distant galaxies seem to contradict data from the cosmic microwave background, like two versions of the same story that refuse to line up. Scientists call this the cosmological tension, but that's putting it gently, because these mismatches suggest something more than a calculation error. They hint that the structure of the universe itself may be warped or worse, built on assumptions that no longer hold. And the deeper Webb looks, the more those assumptions begin to crumble. Galaxies forming too early, stars appearing older than the universe, a strange synchrony in spin direction across thousands of galaxies when randomness was supposed to rule. One researcher described it like this. It's like looking at a forest and realizing all the trees are growing in a perfect spiral. You're not in a forest, you're in a pattern. But who or what said it? If galaxies are strange, planets are even stranger. Thanks to Webb, astronomers have started to directly observe exoplanets with unprecedented clarity. And what they're finding is bending expectations across the board. There's a planet with one side locked in eternal sunrise and another where sunset burns hotter than the day. There are gas giants colder than ice and marshmallow planets with atmospheres so fluffy they shouldn't even hold together. But the most haunting discoveries aren't just exotic. They're personal. Water vapor found inside the habitable zone of a young solar system. Carbon dioxide on the surface of Europa, likely leaking from a subsurface ocean. Auroras over a rogue brown dwarf that isn't even orbiting a star. Each of these findings chips away at the idea that Earth is special, that our solar system is unique, that life or something like it isn't possible elsewhere. And while we haven't found aliens, not yet, Webb is quietly rewriting the rules for where life can form and how easily it might slip through the cracks of our assumptions. Webb's most powerful gift isn't just vision, it's awareness. Because the more we observe the cosmos, the more it feels like the cosmos is responding. Light bends around invisible mass. Structures emerge that shouldn't exist. Filaments of gas form shapes eerily reminiscent of fingerprints. Shock waves ripple like echoes in a chamber. And timelines bend in ways that feel less like physics and more like design. In the Serpens Nebula, magnetic fields align newborn stars with uncanny precision as if guided. In the Southern Ring Nebula, concentric dust shells form every 8 years, like clockwork, marking time like tree rings. Each one a frozen heartbeat in the history of a dying star. Some researchers whisper about simulation theory. Others talk about cosmic code. But Webb doesn't need to find an alien spaceship to raise eyebrows, because what it is finding suggests something just as powerful. A universe full of rules, structures, boundaries, and maybe watchers. And if that's true, then the scariest thing isn't what we see. It's what might be seeing us. Among Webb's most disorienting revelations is the appearance of stars that simply shouldn't be there. We're talking about stellar bodies so old, so chemically evolved, that their mere presence defies the established timeline of the universe. Some of these stars, glowing with heavy elements like iron and oxygen, appear in galaxies that formed less than 400 million years after the Big Bang. But that's not enough time. Not by a long shot, for stars to be born, die, explode as supernova, and then seed the universe with those elements. It's as if the timeline skipped a few chapters and jumped ahead. And if stars are forming with enriched chemistry before the universe even had time to make those ingredients, then the very chronology of cosmic evolution is in jeopardy. Some astrophysicists now suggest we may need to rethink not just the when, but the how of star formation. Others go further, proposing that cosmic time might not be linear at all. That maybe, just maybe, there are loops, folds, or echoes. If that's true, then Webb hasn't just discovered new stars. It has torn a hole in time itself. Webb was also built to investigate the most elusive element in the universe, dark matter. And yet, instead of shedding light, its discoveries have only deepened the darkness. The galaxies that Webb captures are too structured, too massive, and too orderly for their age, unless there's something invisible holding them together. But here's the twist. The way these galaxies behave doesn't match our models of how dark matter should function. If dark matter is the glue of the cosmos, then it's not behaving like any adhesive we've ever theorized. It's as if there's a ghost behind the curtain guiding gravity with a hidden hand, but not obeying any known rule book. In some systems, the gravitational effects appear exaggerated, as if dark matter isn't just present, but aware. Could there be more than one type of dark matter? Could it interact in ways we haven't imagined? Or could it be something else entirely? Something conscious, structured, or even ancient? Whatever the answer, Webb is dragging our understanding of matter out into the cold and forcing us to stare into the void and wonder if something is staring back. Cosmologists have long believed in the cosmological principle that on a large enough scale, the universe is uniform and unstructured. But James Webb is obliterating that belief. In its deep field images, patterns emerge, repeating structures, spiral alignments, star clusters arranged with near-geometric precision, massive cosmic filaments stretching like arteries through the universe, connecting galaxies across unimaginable distances. Then there's the giant arc, a curved string of galaxies over 3 billion light-years long, so perfectly shaped it almost feels engineered. And the cosmic web, a lattice of dark matter and baryonic gas threading the universe like scaffolding. What if this isn't chaos at all? What if we're looking at the framework of something larger, something planned? It's like opening a random book and finding the words, a line in poetry. Coincidence or construction? If gravity is the architect, then Webb has revealed its floor plan, and it doesn't look like an accident. Perhaps the most unsettling data from Webb comes not from what it sees, but from what it barely sees. There is a point far, far out where light itself begins to behave strangely. Beyond this threshold, galaxies dim too rapidly. Redshifts stretch in inexplicable ways. Time seems to lose consistency. Some call it the cosmological horizon. Others call it the observable edge. But now a few daring theorists are calling it the rendered boundary. They suggest that we might be bumping into the very limits of physical reality itself, as if Webb is scraping against the walls of a simulation. One physicist likened it to a video game engine only rendering what the player can see. If so, Webb isn't just observing the universe. It's revealing the boundaries of its stage. And behind that stage, maybe nothing. Or maybe the observer. Because the deeper we look, the more we realize the universe was never meant to be fully seen. And maybe, just maybe, it's starting to notice that we're watching. We built James Webb to reveal the origins of galaxies, to peer into the nursery of stars, to measure the breadth of exoplanets. But somewhere along the way, we found something else. Something we weren't quite ready for.